Alright, welcome guys. What we're going to be talking about today is current and resistance in circuits. What you need to know before watching this is a general knowledge on what potential difference is and the nature of the flow of charge. What we're going to do is define current and resistance in electric circuits. So what you have in front of you is a battery to the left and some sort of electrical component to the right. In our case, a light bulb. Now, what we remember from before is that charges will flow from a higher potential to a lower potential. Now, inside of a battery is some crazy chemical reaction, and because of this chemical reaction, it causes the one terminal of the battery to have higher potential and one side of the battery to have a lower potential. In our case, the difference between these two potentials is 5 volts. So our potential difference in this battery is 5 volts. Now, if we just stared at it, nothing would happen, of course. It would be pretty boring. But we know that if we form a connection. So I'm connecting it to the battery, to the light bulb. This little coil in the light bulb is also a conductor, so charge can flow through that as well. And we end up to the negative terminal. Now what we've done is connected the plus side to the negative side using a conductor. Now what we know is that if we connect these two, it's like attaching a pipe between two buckets of different height. And what we'll know is that the flow will begin. So the charge will flow like this. It will enter the coils of the light bulb and it will return home to the negative sign where the cycle will continue. Now, of course, when the charges pass through the light bulb is designed to light up when charge flows through it, and it powers the light bulb. Now, what we've just created right now is the simplest form of a circuit. Now, what we're defining circuit as is a closed loop with charge flowing through it. Now, the key word here is closed, because what would happen if we removed one of the wires? There is no longer a connection between the plus terminal and the minus terminal of the battery, and therefore there will be no flow. Of course, when there is no flow, the light bulb will not light up anymore. So that's what a circuit is, a closed loop with charge that flows through it. Now let's talk about current. For the same circuit that we've set up before, let's say we were at this blue point here. And what we're assigned to do is count how much charge passes us every second. So we stand here and we just wait and count every charge that passes us. Let's say we stood there for a second and we counted 100 coulombs of charge in a single second, so 100 coulombs per second. Now the unit of current is amperes, A, so we say that this circuit has 100 amps of current throughout it. Now what current means is how much flow is happening inside this circuit. Just like an air current or a water current, current just describes the motion of something. So a larger electrical current means that there is more flow, there is more charge passing a particular point every second. Of course, if you're at this blue point or if you're at this blue point, the currents won't be any different because the flow has to go into the same direction and the flows are going to be exactly the same. So what we're going to define current to be is the amount of charge passing a point every second. The symbol for current is I, its unit is amperes, and the symbol for the unit is A. Finally, let's talk about resistance. So what I want you to imagine the wire to be is, say, a 3-lane highway with cars traveling through it, and the cars are each some charge. Now, in our 3-lane highway here, our cars are traveling around 100 kilometers an hour. Now, what I want you to imagine is, what if we suddenly merged this highway to become a single road as opposed to 3 lanes? Of course, what you can imagine is that the cars will have to slow down to allow each other to pass through without crashing into each other. And they were going 100 kilometers before, but now they're going to have to go a lot slower so they don't crash into each other and go maybe 20 kilometers an hour. So what I want you to imagine resistance to be is something like a speed limit. Resistance describes how much charge is allowed to flow within a component or within a circuit. So for a low resistance value, this means that the speed limit is higher. The cars are allowed to go faster. There are more lanes for the charges to travel on. But for a circuit that has high resistance, that means that the charges can't flow as fast, they can't flow as easily, there are not as many lanes as there are before. So resistance is a description of how much charge is allowed to flow. Of course, a higher resistance means less flow, a lower resistance means higher flow. The symbol for resistance is R, and its unit is ohms, represented by the symbol omega. So really quickly to summarize, current is a measure of how much charge passes a point every second, and resistance is a measure of how much flow is allowed through that circuit or through a particular component. If there are any questions, shoot them at me. Otherwise, thank you for watching.